Welcome, folks. In the first video of this unit, we learned about central angles and inscribed angles, two special types of angles that are formed within the circle. This video is going to kick that level of knowledge up a bit, and we're going to talk about some different types of angles that are formed in the circle. Before we do that, though, I want to go ahead and define three types of line/line segments so that we can talk about these segments as it pertains to the formation of the angle. So the first vocab word that you're going to need to know is the word tangent. This isn't tangent as it refers to trig, like sine, cosine, and tangent. This is a different type of tangent. When we talk about tangent with respect to a circle, we're talking about a line or part of a line that intersects the circle at exactly one point. So if I were to look over at the picture that they very nicely provided for me here in the notes, line CD, at least I think that's a C, and that's a D. So line CD or line DC would intersect that circle at exactly one point, making line CD a tangent. So for example here, line CD. Now a secant, on the other hand, is still going to be a line or part of a line, but it intersects the circle at 2 points. So I might get my highlighter out here just to differentiate between the two. So if I'm looking over here at my picture, line either, I'm going to go ahead and rename that point so that I can talk about it. Line DE is a line that intersects the circle in exactly 2 places, and it therefore is a nice example of a secant. And then a chord we learned about in the last video. A chord is different from the first two in that a chord is not a line. A chord is a line segment whose endpoints lie on the circle. So there are in that picture a lot of different chords. I'm going to pick one. How about chord AC? Endpoints are on the circle. That makes him a chord. All right, for this video, the most important question you're going to ask yourself over and over and over again is, where is the vertex? Because the location of the vertex is going to drive which rule you use to apply to solve the problem. But in order to find the vertex, we have to know what a vertex is. Vertex, remember, is going to be the point where the sides of the angle come together. I'm going to, I think, every time I look at an example, I'm going to mark my vertex with a little star because it really, truly is that important. If we think back to the first video on this unit, we think back to inscribed angle. Remember, an inscribed angle is an angle that's formed by two chords. His vertex is on the circle. So when I go look at the picture here, vertex of this angle is going to be point B. It's the point where the two sides come together. And remember from the first video that the measure of an inscribed angle is going to be equal to half that of his intercepted arc. So in this picture, the measure of angle ABC is going to be half of his intercepted arc. His intercepted arc is arc AC, which has degree measure of 100. So X is going to be equal to half of 100, or in other words, 50. That's review. Why it's nice to look at that is because when we go take a look at the next example, the example of an angle that's formed by a tangent in a chord, note the location of his vertex also. His vertex also lies on the circle. Like the inscribed angle, his angle measure is half that of the arc that he intercepts. So if I look at that picture, the angle is going to be angle ABC. The arc that's intercepted by that angle is going to be the arc that lies within that angle, or 120 degrees. So the measure of angle ABC, and I can't see if I covered it up now, there's probably an X under there. I'm just going to call it angle ABC is going to be equal to half of the 120-degree arc that it intercepts, or in other words, 60 degrees. And again, there might be an X hiding behind there. But again, notice that in both of these instances, vertex is on the circle, angle measure is half the arc. I'm seeing kind of a theme emerge here. The next example we have to look at is the angle formed by a tangent and a radius. Remember, a tangent is going to bump the circle in exactly one point. So in this picture, line AB or line AD is a tangent. OD is a radius of the circle. This one says that if a line is tangent to a circle, it's going to either be perpendicular or form a right angle with the radius that's drawn to that point of tangency. Here's how come, and especially as honor students, you should understand this. When I look at the vertex of the angle is there at point D. He's on the circle. So if he's going to follow the example that the first two set for us, his vertex is on the circle, so his angle measure should be half of the arc. Well, if I were to take and extend that radius and create a whole diameter, well, the arc that intercepts is going to be the arc that is the semicircle with measure 180 degrees. Half of 180 degrees is 90. And again, you can see now, or hopefully see now, why when his vertex is on the circle, angle measure is half the arc. So everybody in that first part of the video, everybody in that first category had a vertex that's on the circle, angle measure was half the arc. Let's take a look at what happens when we move the vertex outside the circle. So if I look down here at this next example, vertex here is outside the circle. The rule for an angle whose vertex is outside the circle says that the angle measure equals half of the difference of the two arcs that angle intercepts. So this is a little different. Let's go take a look at the two arcs that angle intercepts. So those red line segments represent our angles. One of the arcs is going to be that major arc of 260 degrees. The second of those arcs is going to be the minor arc of 100 degrees. So I'm going to say the measure of my angle ABC is going to be half of the difference. So arc AC is 260, minor arc AC is 100. And when I do the 260 minus 100, I get 160. Half of 160 is 80 degrees. So the measure of angle ABC, 80 degrees. All right, likewise, in the next example, we've got the same scenario going on where the vertex of our angle is outside the circle. So again, there's our vertex outside the circle. Because his vertex is outside the circle, the rule that we're going to follow is that the angle equals half of the difference of the two arcs that are intercepted. And I can't spell difference. So those red line segments make up our angle. First intercepted arc is the 80 degrees. Second intercepted arc is the 20. The measure of the angle, or x, is going to be half of the difference between 80 and 20, or half of 60, which I'm pretty sure is 30 degrees. So that's our second case scenario where the vertex of the angle lies outside the circle. And it looks to me like we've got one more of these up at the top of the next page. So when I go ahead and flip up, Again, I noticed that the location of the vertex is outside the circle. So the rule when the vertex of the angle is outside the circle, measure of the angle is half the difference of the intercepted arcs. So again, I'm going to go take a look at the red sides of my angle. One of those intercepted arcs is the 100. The other of those intercepted arcs is the 30. So my angle measure is going to be half the difference of the 100 and the 30. Or in other words, 35 degrees. So again, when the angle's outside the circle, rule says the angle measure is half the difference of the intercepted arcs. All right, in the next case scenario, let's go take a look and see what happens when the vertex is inside the circle, but not at the center. So when I take a look here, notice that the vertex is inside the circle, but not at center O. If I think about the degree measures of the vertical angles that are formed there, I've got two angles that are equal in measure to each other. We've known this since the beginning of the school year, so nothing new there. But if I look at the arcs, one of the arcs for one of those angles is 70. The arc for the other angle, 170. So even though the angles are equal in measure, their intercepted arcs are not. The way that I'm going to account for this is I'm going to take an average of those two arcs. So anytime I have an angle whose vertex is inside the circle, I'm going to find the angle measure by taking half of the sum of the two intercepted arcs, or in other words, the average of the two intercepted arcs. So in this instance, the measure of angle BED, or X, is going to be half of the sum of 170 and 70. Or in other words, half of 240, which I'm thinking is 120. All right, and then the last one is review. What happens when we have an angle whose vertex is inside the circle and at the center of that circle? So that's the piece that's different here. We're looking at the center. Well, this is review from the previous video. Anytime we have a central angle, the degree measure of the angle is going to be equal to that of its intercepted arc. So angle equals arc, making the number of degrees in angle X 80 degrees. So in summary, this is a really nice chart down at the bottom here. In summary, when our vertex is at the center of the circle, degree measure of the angle is going to equal the degree measure of the arc. When we're inside the circle but not at its center, that's when we're going to have to average those two arcs. So degree measure of the angle is going to be half the sum of its intercepted arcs. When our vertex of our angle is outside the circle, the degree measure of the angle is going to be half the difference of the two intercepted arcs. And lastly, when we are on the circle, our angle measure is going to be half that of the intercepted arc. Notice the double stars there. There is an exception that goes along with that rule, but I think in the interest of time, I'm going to halt right now and we'll talk about that exception next time I see you back at class. As always, thanks for the gift of your time and watching the video, and I look forward to seeing you next time we're able to meet together. Till then, take care.